Hey everyone, today we will talk about a problem statement, partition list. This is a linked list problem statement. In the Leetcode, it is tagged as the medium level problem statement. Now let us go through the problem statement. It says, given the head of a linked list and a value x, partition it such that all nodes less than x come before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. Alright, now let's understand with the help of an example. So we have an example 1, 4, 3, 2, 5, 2. This is a given linked list and the target value is 3. Alright. So it says that we have to partition the list such that all nodes less than 3 comes before nodes greater than or equal to 3. So 1 is smaller than 3, yes. 4 is greater than 3, okay, it will be in some the list. 3 is equal to 3, so it will be here. 2 is less than 3, yes. 5 is less than 3, no. 2 is less than 3, yes. So this will be our final answer. And we have to write a program for this only. Now let us understand how we will solve this problem. So we will create two separate lists. Let's suppose we name as the smaller list and the other one is larger. The smaller list will contain numbers as 1, 2 and 2. The bigger one will contain 4, 3 and 5. And finally, if we merge these two lists, these one, so it will become 1, 2, 2, 4, 3, 5, which will be our answer. And how we will create these two separate lists? So we'll create two pointers. Let's name them as the smaller list S and the larger list L. Initially, we will start traversing the list, the given list, which is I'll write it here 1, 4, 3, 2, 2, 5, and we'll start from this first element. So let's make it as C as a current pointer on the given input list. We are at 1. Now 1 is less than the target element, which was 3, so this is x. So 1 will be appended to the smaller list. The next we'll go to 4. 4 is greater than 3, so it will append to this list, the larger list. The next is 3. 3 is equal to the given element, and as per our problem statement, all the numbers less than the given element will come before. So if it is equal, it will go to the larger list. The next element is 2. It is less than the given target, so it will come to the small list. Again, the next element is 2, so it will also come to the small list. And the next element is 5. It will go to the bigger list. And since 5 was the last element, these will be our final lists. And that's how we'll separate the given linked list. Okay, what will be the time complexity for this solution? So we are traversing this list one time, so it will be O of n, where n is the number of input elements. Space complexity. So since it is a linked list and we are only changing the pointers, for example, this is our input list. We are just breaking these into two separate lists and rearranging them. So space complexity is O of 1, as we are not using any extra space. Now we will move on to the coding part. So here we have as s equals to null, s equals to null, sh equals to null, s, lh equals to null. So basically this is for larger, this is for smaller edge. And we have another pointer current as equals to h. Now while my current is not equals to null, if my current dot value is less than x, I'll have to append it on sc equals to null, so current sh equals to current, else sc dot next equals to current, c equals to current, states data. Else if my lc equals to l, c equals to current, ls equals to current, else it has to be curly braces. This will be kept. Alright, else lc dot next equals to current, lc equals to current, and finally we'll have current equal to current dot next, so that we iterate over the interest. Now if my sc is not equals to null, sc dot next equals to null, my lc is not equals to null, lc dot next is equals to null, my sh is not equals to null, sc dot next equals to lh, return sh, else return lh. Okay, so we have completed our code. I'll just explain. So these are the couple of pointers that we are using. So this is the point, these two pointers are for the two heads for the two sub list, smaller and the larger. These two pointers are the current pointer on the smaller and the larger, and this is the current pointer on the list, input list, on which we'll be iterating. So we iterate over the list, and if the value is less than the x, the given target value, we append it on the smaller list. If it is greater than or equal to, append on the larger list. And finally we just append the larger list to the end of the smaller list and return that. Now in case there is a list in which there are no elements smaller than the given target, so our smaller head will be null, so we'll just return the larger list. We'll just run the function. I have created this node, this sample input. We'll run the function, and you can see that our list is partitioned. So thank you for watching the video. If you want to see more such videos, please subscribe to the channel. I'll make more videos on different type of Leetcode problems. I'm starting with the currently medium level problems. Going forward, I'll make for stacks, queues, trees, graphs. I'll also release lectures on those, and eventually we'll talk about the hard problems as well, and we'll discuss about different interview problems. Thank you.